Take me back where I belong, where the trees grow up so long, where the summer ain't got no end, and the water flows on white sand. Where I belong, grow up so long, where I belong, grow up so long, where I belong. Take me back to the place I love, the place I like, and the place that I miss.
Hello everyone, on Pi and AI Noida, and that's where we are going to discuss about AI on mobile web. Let's wait for a couple of minutes till everybody joins, and I hope everybody is working fine. This would have been your best week ever, and let's pray to make your session today wonderful and learn some cool new things. And by the way, this is our first event that we are doing along with Deeplearning.ai. That's called Pi and AI, and Noida is their first chapter, and we'll be doing correspondingly more sessions in today's what we are going to do. So the main talk theme and everything will be going to be around AI on mobile web, but we'll be covering other aspects of AI and machine learning also. So for those of you who still don't know about what Mobile-web.dev is, Mobile-web.dev is an open source community for mobile web technologies where we discuss about mobile end. So these technologies include AMP, Flutter, Angular, PWA. Some more spice and flavor to what we are actually doing over here, and that's why we switched into more kind of mainstream AI and ML. So we hope that this will be helpful in transiting into this kind of stuff, and we hope to do these more kind of these kind of events. So we were approached by Deeplearning.ai, and if some of you who know about what Deeplearning.ai is, Andrew NG, obviously that name suggests. So it's a meetup which is kind of in collaboration with Deeplearning.ai, and they are the one who are kind of giving us advice on how we should do event and all that. So a good gift for all of you who are here today is that we will be forwarding your email addresses which you use for sign up to Deeplearning.ai, and you can avail a good discount. I'm sure we're getting a discount on the Andrew NG Deeplearning.ai course, so you should definitely check it out. We'll be going to send you a follow-up email on that also. If you haven't registered with our meetup, so please go there so you can avail those discounts. So, but when the Pi and AI thing was coming, people actually imagined that Andrew is going to start a new Pi business, and that's those Pis are going to be made with AI. But that's how we developer people actually think in that direction. That's actually not the Pi and AI. This is actually the Pi and AI that we are going to talk about. That's you are holding a nice pie of application development, and then AI is helping you to create awesome application development, right? So that's what community is about, and that's what we are going to do today. So with this, let me introduce myself. I am Aman Sharma. I am the founder and CTO at Twimbit. I'm the founder and lead at Mobile-web.dev, this community that is helping you to learn more new technologies. And I'm also a Deeplearning.ai and OS and then this is my team. And yeah, that's a little bit about me. And then we have our extreme personality. Rabimba, would you like to do it?
Hi, everyone. So I'm an AI engineer consultant at Twimbit. I'm also a Google expert in web technologies. I'm mostly interested in web textual applications, and I'm also a motivational speaker. Today, we're going to talk about a lot of interesting things which are happening in machine learning and how you can actually have them in a web application and still build cool things.
Awesome. So this brings to our agenda what we'll be covering today. So firstly, we'll be going through what AI is. For some of you who still are confused with what AI is, like, we'll just quickly go through what AI is and what are the different AI branches that actually makes AI possible. And also what AI on web actually means, why we are talking about this term now after AI has been so successful with Python and scripting language like that. Then we'll see what are the benefits of being AI on web, what is machine learning. So Rabimba will be going much deeper into what machine learning actually is, how you can bring ML into JavaScript, that's the mainstream way of how you can create AI on web. And then we'll talk about few of the applications that you can create easily with using AI and machine learning, and that would be a fun way to implement AI in your day-to-day projects. So what is AI? What's AI? There are different ways to ask this question. Some of you may already know that it's artificial intelligence. And to simply like explain like what the closest bookish definition I can come up with, it's a tendency to create intelligence artificially. Right? If I'm incorrect somewhere, you can drop me your suggestions in the comment. I'll be really happy to correct myself. But what I actually really believe is AI is the computer thinking like humans. That's the most easiest way that I can explain. Right now, computers are like so advanced. You can do pretty much everything on computers. Like they can, create memes themselves. They can create so many kind of different filters and stuff like this. But what actually AI enables them to do is that they can think on themselves. You don't need to write programmatic code to do that thing. So that's what actually AI means in that sense. So when we talk about this, I guess like most people see and remember their ages when they saw Iron Man for the first time. Isn't Jarvis the best example for AI, right? But I guess we are still far from that future. I think what close to AI we can say in today's world is Netflix giving you recommendations, or like Gmail telling you which email is spam or not, Siri helping you out with your stupid questions. And some of you who are single, they will be flirting with Siri all the time. So that's what way how AI is helping you. And Airbnb tagging different pictures of property so that you can best find your property. I'm not sure like if so. Everybody over here has tried Airbnb this feature. They have implemented a new cool feature which automatically tags photos of homes with relevant feedbacks. So that's a good way they are using AI. And then we have our self-driving car from Mr. Elon Musk, who is amazing fellow, and I really, kind of admire him a lot. And this is what AI is actually doing. So we are still far from what Jarvis can actually do, but these are the things that we can do today. But it's very easy to get lost in the way what actually AI means. There are a lot of things that are going on, you know. So to like simplify what are the different branches of AI and how actually AI deals with different things, you can imagine AI as this circle, where this whole bubble of circle is the whole AI subject. Then inside AI you have another sub-subject that is called machine learning. So that is basically an AI branch where we train machines to learn themselves, and we don't write a code altogether for it, and just machine learns from its own mistakes. And that's what machine learning is. In the coming slides, we'll Rabimba will be telling us about how you can actually benefit from machine learning and how it's actually done. Then there is something that is not a new concept. It has been for since 1980s, as far as I remember, neural nets. But with mainstream computation, quantum computers, and things like that coming into, neural networks have been very popular recently, and they are responsible for major AI tasks that's going on. And then you have deep learning, and that's the deepest point in our whole AI pool. So what actually deep learning means is deepest branch of neural nets, and I think better than me, I think Rabimba would be able to explain, but I am like more kind of fictional person, so I'll explain you in a fictional way. Imagine like this is the closest AI that thinks like human, where we give its creative choices, it automatically predicts and does things on its own. So that's the whole architecture of what a circle of AI actually looks like. Now, to see the previous examples that we were seeing, again, there are different algorithms and different branches of how machine learning and AI is divided into. So the first one that is most popularly used is called recommendation systems. It's predicted like almost 75% of today's internet or any AI product relies on recommendation system for an enhanced user experience. So it actually uses machine learning to generate results based on your interests. So based on your previous watching history on Netflix or what kind of interest you belongs to, Netflix recommends you more shows. So that's part of recommendation system. Then the next one you have is spam filter. This is the most popular one. It's not if you would like to write all the regex rules in forms of what email is a spam or not. I think you will end up with writing a lot longer line of code. But a spam filter uses a simple machine learning algorithm, which is based on naive Bayes algorithm, and remember we'll be talking about that too. And so that what it actually does, it makes a prediction probability guess of if the email is spam or not, and then with repetitive enhancement and feeding its training data, it gets smarter with time, and it automatically recognizes if an email is spam or not. For those of you joining, hello everyone. I have seen a lot of highs. Hi, hello everyone. So yeah, and don't forget to drop me any questions at any point you want. We want totally this to be interactive. So at any point you don't like my joke, like Jarvis from the Tony Stark movie, I'm totally happy with it in order to improve my skills in joking. So that's another way to make it interactive. So next, for those singles of you who try to flirt with Siri a lot, so you are not, maybe I'm the only guy, but still, how actually it works, it uses neural nets and it implements a technique called natural language processing to process analog sounds. Whatever we speak is in form of analog, to convert into digital waves, then amplify them and convert them into machine understandable way. Machine don't understand what I'm trying to say right now, or it can't understand what is a joke or not. But like simplified way, like when the data is processed through neural nets and when it passes through natural language processing filters, it's much easier for it to come up with those kind of stream data. And that's where the power of the whole neural net lies in the current applications. So next, talking about computer vision is another example of a great example of how AI is working these days. It actually uses a different object detection, machine learning algorithms, and all that to classify different various objects based on their shapes and based on the past data, and then it labels the data. And when you improve that and add more and more features, that how actually computer vision actually works. Then last but not the least, self-driving cars. That's the most exciting invention of this century. It uses again deep learning to identify objects and classify things which are beyond human capabilities. Like really, self-driving cars exist. A Tesla Model S or any other car would be able to far think ahead about different consequences and will have a far greater response time than a normal human being. And this has been only made possible by repetitive machine learning and using deep learning techniques. Let's talk about what AI looks like. At the same time, we shouldn't forget that all these things that we are doing right now, even you watching YouTube right now on your mobile or on desktop, wherever you're watching it, it has only been made possible by internet. So a lot of traffic even from different countries. Like nobody can imagine if there was no internet, how would we doing all these things, especially in this pandemic era. So if you imagine a traditional application that runs AI on its web platform, this is what the usual flow looks like. You have your own application running on a device. It can be a normal front-end app or a website like Amazon.com. And whenever a person comes to this platform, he makes a request to the backend API. So this backend API may contain some kind of logic that takes the request and has the responsibility to respond. But if it is a smarter logic like giving predictions about something or giving recommendations, then it might take another step and go to another algorithm running on another server, and will get back with the response to the backend API, which will send back the response to that application. Occasionally, this backend API will also kind of get training data from the ML model to improve its classification capabilities, to improve the results, and that's where the power of machine learning lies, the capability to improve itself over time, and that's is done occasionally. And also at the same time, backend API is sending some kind of data to the warehouse, which includes analytics or the logs of what people like or what people don't. And these logs are then again used to retrain the model and are created in form of ML model, and then which goes back to the AI algorithm and goes back to the backend. So this is not actually how application code would look like. It's more like how it actually functions in form of the architecture. Now this process looks fine, and most of the applications and works in this way. No problem, no problem at all actually. But that's too long. I mean, like, it's taking around, I think, 4, 5, 6 steps in order to get your recommendation. And if you are starting developer, those kind of iterations will not actually land you with some good results. So let's do this thing. Let's try the mean way of solving this problem. Let's create a shortcut. If you have seen this thing floating around internet a lot, let's bring our drift car, which is our application in this case. And normally you will go along with the long route of normal AI. But we'll see that the shortcut here is AI and web. And what we are going to do, we are going to remove all these steps that we were talking about before. So no backend API, you don't need to travel to any backend API, you don't need to go to any AI algo running on server. I mean, like, who has time to go to all these steps? What we'll do, we'll simply run our AI code on the device itself. If it's a web app, it will run simply its code on the mobile itself, like how progressive web app functions or any other applications like that functions. Now, to enable this, you might need a little bit of kind of intermediary data that still exists over there, but it won't be that quite often that you see usually in your normal web application process. So it will be occasionally going to the backend server, getting the ML model, storing it in a local device machine, and then running the results. And that's what actually AI on web means. So if you see this diagram here, we have a clear difference between how a conventional AI and how a AI on web actually looks like. So in a conventional AI, these are the steps that you will perform. You will build your project, you will train your project with different training data set. You will test it. If it works fine, you will move it to deploy. Then you have all sets of different cloud providers like Google Cloud Platform or Amazon Web Services to enable this. And then your project that is running on JavaScript will be talking with the deploy project that we talked in the previous slide, and then it will be giving out the results. But AI on web actually changes the whole approach. It says that whatever you are doing, it should be done on the client browser itself. The building, training, test, and run, it should be done on the client browser only. And when needed, it should be on the basis of on when needed basis. Like if a progressive web app code is changed, then only it should download a new version. And the benefits are like it works like a native app. It has offline capabilities, and the same code we are implementing on our AI on web. We store a chunk of JavaScript code on the web portal itself, so that it doesn't need to create that code. Now, talking about the benefits, why would you actually consider something like this? So obviously there is lesser turnaround. That means you don't need to make sure about your architecture running 24/7 with a good CDN all around the world. You don't need to worry about all these things at all, and it would be taking much lesser time in releasing output than it would conventionally with any other application platform. Also, you can design the UX of the whole application, in the user experience, based on the personalization of a single person. If it's a chatbot running on the website, imagine the capability that your website will be responding with those customized questions for those particular users. And for the rest of them, it's like a normal website. But with AI on web running on your website, it would change the whole web experience with on-the-go changes, personalization, and things like that. And also, you might not know this, but if you do a Google search on your friend's desktop and you do a Google search on your laptop, it might give different results. And that's just because it's doing personalization of the content and the sequence on the way. You don't see the same Amazon home screen as your friend. And that's the way how personalization of content works on the web. So this is also a great aspect of dealing with AI on web application. You can provide a bespoke native UI to any kind of user who's coming to the platform, and he'll enjoy, the personalization that you are bringing to the platform. He will never leave your website, and that's the way to increase revenue, overall engagement, and things like that. And also, you can add some nifty features like voice search and voice like live chat and things like that. That runs on the browser only. You don't need to set up a backend. So that's also some cool things that you can do with AI on web. And now I would hand over this to our very own Rabimba to like talk more deep into this tech thing, and let's see what he has for us.
Thank you, Aman. So, what is machine learning? Aman has described some of the use cases of machine learning and everything we know about it, and why it's used and why we might want to use it completely in our browser. Before we delve into it, how does it actually differ based on our traditional approaches? Now, take an example of recognizing spam emails. So almost all of us have received spam emails in our webmails. And if you are from an age where you have used Yahoo Mail or Hotmail a lot, you might know once upon a time it used to be kind of like a regular core that you log into your email and just delete a lot of spam emails, then you go to your normal emails. With Gmail, they completely revolutionized them, and we have much less number of emails, and now almost everybody is as good as them. Now, what has changed? So let's take these two examples. On the left side, we are trying to catch specific things, specific spam emails, by writing rules. So for example, it's literally checking all my emails and everything, that if there are specific stop words, for example, if there is a Viagra, or if there is anything else which are in the email which I don't want them to be, and I would classify them as a spam email. That's like just basic rule. Now, on the right-hand side, for the same thing, we are actually loading something that is our model JSON. That is a model we have trained on a lot of spam emails. By train, I mean you have certain number of features which we would consider as characters of spam emails. We have trained upon them, and then we are comparing that with our emails. That is, what is the prediction? Is it matching with the pattern? How much is it matching? But then we'll have a threshold of our prediction score, and based on that, we'll say if it is spam or not. So immediately you will see between these two approaches, on the left side, it's kind of rigid, that only the keywords, only the stop words we are putting, it will only be able to stop those. If somebody gets crafty, not only on the stop word side, maybe using characters, using specially crafted characters, which are not Unicode or something, they can kind of throw our system off. On the right side, since it looks for pattern, it's not so easy to actually fool that system, even for this very basic example. Now, what are some of the algorithms which are used? There are a lot, but we're going to talk about a few of them and when and in which use cases where they're used mostly. So we have naive Bayes, k-nearest algorithm or k-means algorithm, linear regression, convolutional neural network or CNN, and long short-term memory. I can say you some of the use cases where they are mostly used. For example, the recommendation system you have been seeing, or maybe you want to generate some text. If you want to generate some text, the most commonly used algorithms are LSTM. And if you want to detect anomaly or detect similar type of behavior, k-nearest algorithm or k-means algorithm might be your choice of algorithm for that. So these are kind of the statistical algorithms we use to kind of detect patterns or detect similar behavior or kind of generate similar behavior. So regarding what kind of machine learning do we have and what are we going to talk about today? So we have supervised, unsupervised, and reinforcement learning. Now, starting with supervised learning, which and the two we are going to talk about mostly today. So when it's a supervised learning, you have a certain number of data set and you have your predictions. Now, based on supervised learning, you predict based on the set of features and labels available to you. You actually label the data set and you run your algorithm based on that labeled data set, from where your algorithm learns that, okay, these are the features and these features are assigned to this label. So in my untrained data set, these kind of the things which I would classify. So if we go through, for example, these specific three things, we would say for predictive model, these are kind of the mathematical functions that are going to work on that. Now, what are the labels? These are the classification for each entry. For example, is it working on the price or like a name, something. Now, the features are your attributes. These are most important. thing in a machine learning algorithm. So you have to carefully detect features, and this is where supervision comes in, that you have to look at your data and select that for this data, these are the features which are important for me. So the rooms, number of floors, what type of location this house is in, is it which kind of property, and with that we might be able to create a supervised learning algorithm which tells you, okay, these kind of real estate in Bangalore or Noida, and these kind of houses are in these kind of locations probably will have these range of prices based on this algorithm. So that is kind of like supervised learning, where the features are carefully selected by us. Now, for the unsupervised learning part, this is the same ability to create predictions, but only on a set of features. For example, we don't have to classify the dataset. Here, the algorithm tries to get the classification by itself by running throughout the data, and it tries to predict the customer behavior based on what it's already available to it, and we did not classify them. Now, there are good and bad approaches to both of them. Before we go there, we are gonna try to see how these can benefit us in JavaScript, and then we will try to actually apply this today in some of the web applications and see how it performs. So machine learning in JavaScript. Why? Because it's accessible, it's easier, and it's always available. For example, if I want to write something here, if I want to write something today to show to all of you, what can I show you? If I want to write a very easy algorithm to detect some objects on a pre-trained database, pre-trained data set, maybe I want to detect some bottles or some mobile phones. I just want to write a quick algorithm which literally takes pictures of these and tries to detect, okay, this is a bottle, this is not a bottle, this is a mobile phone, or this is something, right? And I have a pre-trained data set available. Now, for a traditional approach, you would actually run it in a powerful machine or server. You'd send those information there, and it would run there and give it back to you. I want to do it everything in my phone because this is a lightweight task which my phone or computer should be able to handle. That's why we actually try to do it in JavaScript. Now, that brings us to rapid prototyping. When we have an existing model, when we don't have to train our model, we have trained our model in already powerful machines with GPUs, and then we have the pre-trained models available. Why cannot we have it in JavaScript just on that model to run it? That gives us quick prototyping ability and quickly build applications which can run in browser and mobiles. Not only that, this also gives us the ability to reach a large mass who don't have access to maybe powerful machines, or who might want to consume them completely on mobile, and which are not coming from my server. So it might be able to run a web page just as an offline purpose. So progressive web app kind of situations. The other thing we want to express is when you have to build it in a web, it has a big ecosystem. This you can kind of see right now. When I'm going to show the demos, I will just pop up a URL, and all of you can actually experience this right now without any preparation or any special computers at your side, or even from regarding my side, I don't have to build a complex architecture or complex website which talks to a server and gets these nothing. I will just write it in a maybe JS bin, or just a glitch presentation, or just a normal web page which has HTML and JavaScript, and you will be able to see that, okay, this is running. So this big ecosystem where you can just have others immediately hop into your experience is awesome to have. Now, some of the things, what can you do right now? And what can we do today in this short presentation? So we'll try to go through a few of the examples. So the easiest thing we can do is we have some trained models already available. For example, the PostNet from TensorFlow, Google, and all of these things which we can actually import. And then we can retrain it for our own purposes and then run models entirely on that. So for today's example, we'll learn to see how we can do that. some of the tools you will eventually use, or you might want to use for web, is TensorFlow.js, Keras, MLKit. It's also as a service available in Google Cloud Compute, Amazon Web Services, and others. ML5. So here, for example, one of the very popular libraries is TensorFlow.js. What does it do? So in TensorFlow.js, how TensorFlow works is that you have the JavaScript library on the front, and then inside you have the estimators. These are your models in the box. So this is something like Postnet. And this is built on the estimator and Keras models, which will run in the background. So for example, one of the demos will show it runs in TensorFlow. It also builds on the models we have before. Now, in the back, it has a Python or C++ frontend based on where you are running it. Then you have the distribution execution engine, which completely specially optimizes that for your device. So if you want to run it in Android, you will have a lightweight engine which runs inside your Android phone. That is for if you want to have a dedicated TensorFlow Android application. If you want to have it running in your browser completely will run it inside as a JavaScript layer. So some of the applications of these. So remember when I was talking to you about LSTM? So I'm guessing you all have seen a lot of people writing in there. Even as when I was in college, we used to get offers that will you be able to do some content writing for us and everything. And that eventually became kind of an inspiration for demos like this, where you can we generate text? Can machine write like our writers? Can machine write like Rabindranath Tagore or Chetan Bhagat maybe? Anyway, so can we generate alternate text? For example, this is a very small demo of if you put a picture, can we generate an alternate text for that? So an alternate text is that when you have a web page and for accessibility purposes, maybe somebody is low on eyesight and they won't be able to see what picture is that. So our accessibility readers will be able to tell you what picture is it. So for accessibility readers to do that, we are encouraged to have an alternate text which describes the picture. What this model does is that this demo takes a picture and it automatically generates a tag for you. What is the tag? For us, it's a tag of a kitten. So it just takes the picture, tries to analyze what picture it is, and generates a tag for it. And so that was trying to define what a picture was. How about not safe for work contents? So this is another example of how you can have something in web page where you might have a website, a forum where you would let people write comments or have pictures or anything on that. Now you want to have a spam kind of filter, but specifically for pictures where you don't want to have specific kind of pictures available to your website. So you can have a system like that, and this is trained on not safe for work pictures or kind of like explicit pictures, where if you have an explicit picture, it will automatically identify as an explicit picture, for example, this hentai, and it will blur it out. Now you can obviously have this same model and run it to your, like train it for your specific purpose, that not explicit picture. I also want pictures which are which probably has a lot of lot of specific scene, or which are specifically indoors, or which specifically has these kind of objects. I don't want them to appear. So you can have this kind of things available right in your browser. Now, this is made by Abhishek, and you should follow this guy. He makes awesome machine learning and mixed reality and a lot of other experimental stuff. So what he did was that he just made a demo where using web and accessibility, you could do a sign language. It interprets the sign language, connects with a Alexa or even Google Home, and speaks out to you. So literally using a webcam, you can have sign language and speak it out for you. So this was a demo he made, and this is kind of like awesome things as an inspiration which you can do. So some demos and code. So first I would try to, wait, let me actually try to do it. Yeah, can I share my screen, Aman? So first, let me actually try to demo you. If it doesn't work, then we'll go back to recording. So you should be able to see my, yes, you are. You should be able to see my mobile screen, and this is a web page, which obviously went to sleep. Okay. So what it does is that okay. Obviously, demos will fail in real time. So as you can see, I don't know if you were able to see that. Yeah, Aman, can you share the slide now? So I don't know if you were clearly able to see the demo. So I'll just go through the video recording here, made specifically if my demo failed in real time. So this is a web page, and you all actually can try it right now on your phone. So what it tries to do is that it tries to take a picture of a bottle, or like a real-time bottle for me here. And this is not specifically for a bottle or anything. So it will try to see if can it recycle it, can I recycle it? And it gives you on the bottom, if you can read that, okay, this is a mobile or this is a phone. For here, this is this a laptop? And if it detects what it is, then it gives you suggestion that, okay, this will go to a recycle bin of this color. This is maybe a recyclable object, so it should go to a recyclable object bin, or this should go to a other bin. This is kind of an example of what you can do. Now, if I want to make something like this, what I want to do, so you should have something which will be a trained model. For example, here we are using the Coco SG model, and inside TensorFlow, I just load the model. Then I initialize the model, and after that, we actually get the element ID from webcam and take the image from the webcam. Once we have it, we try to predict the model that, okay, is this matching, is the pattern matching with what I have trained, and what are my predictions? Is this a bottle? Is this a mobile phone? Is this a spoon? Is this a table? Is this a wine glass? So I did not actually hard code or train this model. This is a pre-trained model. So essentially, if you actually try it on any random object, so if I just right now take it, point it to my laptop, if I point it to my guitar right now, it will try to guess based on what it already has been trained. I don't have to train it to on new objects at all, and I can actually try to guess random objects and predict that, okay, is this something which should be recycled? What is this thing? And get prediction based out of that. That is kind of the power you can have in your if you want to build in website. Now we'll try to, and yeah, surprised, but we'll try to have another demo. So this demo, Aman is most uniquely suited, and this is kind of like an inspiration to another demo we have. So how many of you have played Fruit Ninja before? I think a lot of you. So Amal probably will try to take a live demo, or we can show you in some different way.
Yeah, no problem. I'll be your guinea pig to show you this demo. And let's hope this one doesn't fail this time. So let me put up the screen. Okay, so basically what we have done, yeah, we have something called as Web Ninja. You can also try this app. It says PyAI webninja.glitch.me. So let's try doing that. I have another webcam set up over here. So what I have to do is I'm trying to, oh my god, so I have to not click the bomb, right? But
Yeah,
this
you
banana,
already lost one life.
oh shit, oh no, I'm really bad at it. Maybe let's try it again. Low access to your camera. Yeah, valid place. I guess my camera is like that. So, oh, okay. No, I guess I'm not well suited for this job, but I'll practice on that and try to, improve my skills. I hope that was not the baddest demo of all.
So no, that was actually way better than mine, which kind of classified my water bottle as vase. But anyway, so let me explain what is going on in the background, what actually just happened. So this was literally an inspiration from this demo by Minko, and he's a fellow Google developer expert. So he built that this awesome demo where you can actually stand in front of your computer and try to play Street Fighter uh, using your body, like literally actually fighting. So he used PoseNet to actually detect the poses of body and actually map them and have the fighting. So that is kind of like literally detecting every pose. But we can also detect other things. We can detect our hand. We can actually detect specific activities. For example, when I have hand and when I actually move it around, I can actually detect where my palms are, the finger points, but even them, at least the hands. And I can map it with my movement. And you can have built something like this demo. So if you want to actually play the demo, the code is, actually you can remix the demo as well. So you can just visit this website here. You can just visit the glitch demo here. And this is essentially the code. Let me try to make it bigger. So this is literally the code and how you can actually build this. As you see, this is pretty small, and the only things I have used is the MTD and the object loader are for loading the models. The trail renderer is actually the trails you have been seeing when I'm trying to hit fruit. The trail you are seeing, that is using the trail renderer JavaScript. And here is the model. This is PoseNet. That's allowing us to actually define the pose, detect the pose, and actually make this demo work. So as you can see, you can have this kind of experiences based solely on the web. And this is currently out of our scope for today's session, but this is just like a tip of the iceberg. There are thousands of different things you can do, and thousands of different experiences you can have. If we later have a mixed reality workshop, you will later see that even these kind of concepts you can have in web. Since this is in web, it allows you to have anything which already is in there, have 3D models or anything, have machine learning, work on it, and predict and build cool things. Just like magic, right? So with that, some of the resources we actually used and we would like you to actually have a look at. So we have, so these are kind of the things you should look at. So PostNet was what we used. Teachable machine learning boilerplate is something we really wanted to show, but we did not today. But you should actually have a look. So teachable machine learning boilerplate gives you literally a boilerplate to build your own machine learning kind of like teaching algorithms, and you can actually have it on actually upload pictures or something and train on that. Google Colab is Google's version of kind of like hosted Jupyter Notepad. That is an awesome tool if you are into data science or if you want to do anything in Python, actually have a reproducible way to show that and have a collaborative way to do that. You can also use Jupyter for that as well. And some of the other things, awesome things you want to see is go to the TensorFlow.js examples. They have a lot of examples, and look at go through the community post. People are building super awesome things. For example, Abhishek's hand sign interpreter there. Now, some of the now, if you have any questions to ask, we are open right now. That is kind of all the things we wanted to discuss today. And back to Aman.
Yeah, I guess that was wonderful. I mean, our demos failed. I couldn't squash any of the fruit, but ultimately it was a good learning experience. So we have a couple of questions already over here. So Santosh is asking if we can have this recycler model, the demo that you showed, published somewhere. So
Yes, Santosh, it is already available. And if you go to the Coco SSD model, which was in the slide, and also let me. Okay, so Aman, we will publish the slides, right?
Yep, we'll do that. But
Yeah,
if you
so
want to show them, here is on the slides, you can show that too.
yeah, so actually, if you can just go back to slide number 55. Oh, okay, I am online.
Okay, slide number 55. I'm trying to be the best presenter ever. Yeah, I guess this one. Right?
Yeah. So as you can see, we already have, so this model, the Coco SSD model, that is the one we used. We did not train it ourselves. So you can actually use that.
I hope that answers your question, Santosh. You can use this Coco SSD, which is, I don't think chocolate at all, but is a cool model. Try it out. Any other questions, guys?
Also, Santosh, this demo and what I have trained on it, and this demo, this is also going to be available. This is also available in open source. This I will also put it in GitHub, and will later put it in a comment in this YouTube channel as well.
Sure. So guys, don't forget to link us to Twitter and also follow up Mr. Rabimba to get all these cool demos and cool inspirations all the way. What else? Do you guys have any other question? I hope this was fun. But remember, what do you ultimately think? If you have to create a new application like a simple web app, would you prefer to do it mobile web way or just normal Python API way?
It will kind of depend on what I'm going to build. So for example, small things, for example, this recycle thing or something else, and this can be a good community idea for everybody to work on. Remember when lockdown started, we were worried about how many times we have to wash our hand, and
right.
20 seconds. That okay, are we washing our hand for 20 seconds, right? So why not build something maybe in a web page, in a quickly prototyping thing, where we can actually count how many, if we are actually spending 20 seconds. So one of the easy things will be that if we have our phone with us, just open it, and while we are washing we hand, try to see that if the water sound, can we predict that okay, this is the flow of water, and count 20 seconds from it. So these kind of small things and small interactions, especially the interactions which people are gonna be experiencing them in a situation where they might not have a good internet connection, or you don't need to have information from them to train the data set. Those are the kind of things I would like to build on a website. Which I don't want to build is, for example, the Ninja demo we did today. Even though that was a very cool demo to show, that is realistically won't be very good as a user experience wise. So
Right.
you actually did pretty well playing that, because when I was testing it, if you actually test it in your mobile, you will see the sluggishness of the model running in from mobile side, right? So these are kind of
Yeah.
the experiences we need to be aware of, where the power of web lies and where we should not actually push it too hard right now.
Okay, we lost Rabimba a little bit. That's another web challenges. Guys, if you have any other questions, try to drop it in the comments. We'll be taking them and we'll be asking it. Yeah, remember, so one more question from your end. I have worked with JavaScript and people say that because JavaScript is running on a single thread and you cannot run very much kind of task intensive applications, how would you recommend that challenge? Does that also brings when you are coding AI on web?
This would have been true for quite some time ago, but right now this challenge, at least this specific challenge, can be overcome. So we can have web workers running in parallel. You can have like 16 web workers, which is not recommended, but you can have multiple web workers running in parallel without actually interrupting your main thread. For example, some of these demos or something like this, where you have heavy computation stuff going on, you want your main thread to be a non-blocking thread, so that your web page loads fine, everything looks snappy enough, everyone works in a good like in a proper responsive manner. But while everyone is doing that, your extensive like mathematical computation or anything, maybe you are loading a model with maybe like thousands of small rendering parts, you can offload them to your background workers, and when that is done, you can pass it to your main thread and show that. So that right now you can actually work around that and build stuff based on that.
All right. Okay, so I think that's a wrap. If anybody else has any questions. I hope you like the session, and if you want to like avail a Deeplearning.ai course from NDUNG, if you were participant of this session, I am like kind of glad to tell you that you'll be getting some extra discount on their NDUNG course. That's benefit of collaborating with Deeplearning.ai. So if you have any troubles, you can contact us back, and we'll be helping you out with getting those discounts. All right. Can we have a show of hands if we did well, and if you would like to have similar sessions, that would be a good feedback. We can make a AI on web model for that. Thumbs up. Automatically YouTube gives a like right. No thumbs up. Okay, so with that, thank you for joining for today's session. This was me, Aman, and I had Rabimba with me. Uh, and I hope you enjoyed the session. We help you learn something new, and continue, following us with mobile web, and we'll be bringing out similar session from you all. Thank you, Rabimba, for joining us today.
Thank you, Aman.
Take me back where I belong. Take me back where I belong, where the trees grow up so long, where the summer ain't got no end, and the water flows on white sand. Where I belong. Take me back where I belong. If you want, you can come along. Dance in the night for all around. All our friends will drink alone. Where I belong. Grow up so long. Where I belong. Take me back to the place I love, the place I like, the place that I miss. Take me back.